Vamos a ponerle 2 horas. Ahí está. Ahí estamos.
This line. And that's actually how I started learning to program back in 1982, learning basic, and it was awful. It was spaghetti programming. I was in junior high, and they called it spaghetti code because trying to find a line of logic going through your software was like following a strand of spaghetti in a bowl of spaghetti. It was really hard to figure out what does this program do, because it'd be like all this go-to jumping around everywhere. So that was like just straight spaghetti code, writing things that just ran top to bottom. And then they started to break programming up. They started to create structure. They called it structure programming or object-oriented programming, and they started to break it up where they modularized the code into chunks, and you could have little chunks of code which you could then call and run, and they were in separate files. And so that is kind of like the idea of creating modular software and writing modular code. You break it up into modules, and there's a couple of ways we break things up into modules, into little packages in Go. One is to use functions, so we can take our code and create little functions, which we call, and we can also use packages. And packages allow us to store code, which is like for a similar purpose, into different little packages. Like if you look at the standard library, so if we just go to Golang and we look at the different packages in the standard library, you can see it's all broken up into a common purpose. This is like part of me feeling like I was running through mud today. Like at one point, even right now a little bit, my computer is just like going so slow on the web. It's like, what is happening? So here's like the crypto package, and inside there we have different packages, MD5, different SHA-256, SHA-512, and same, so it's all broken up into packages. So it's organizing your code into little chunks and grouping it together. So functions is a way we do that. And let's get a new thing of code here and refresh this page. Not that one. Go here. There we go. And we'll see how long this takes to load. Part of running through mud. It's like, what is up with my internet? Thank you, finally. Cool. So I could create a function, and a function is going to have this this syntax, and it's going to start with func. And is that a keyword? So we'll go look at the language spec, and we will find out. Language spec, go language program, keywords, and we have the func keyword. So it starts with func, and then it'll have something called a receiver. Okay, and these are a lot like parameters, but it's going to attach it to a type. Attach it to a type. And we'll see how that works. And we're going to have an identifier, and we're going to have parameters. Okay, and then we'll have returns, and you can have multiple ones or a singular, and then you're going to have code. All right, so your code might be represented like this. Like that, be represented like that. So that's the syntax our functions will take. And so here is a func foo that takes in no arguments, it has no parameters, it returns nothing, and then it does something. Cool, so that's all it does. And then I can come up here and I can call foo. And to call it, I have to specify how many arguments I pass in. So when you define a function, it's called a parameter. When you call a function, what you pass in are called arguments. So know the difference between parameters and arguments. When you call it, you pass them in. I'm not passing in any arguments. I'm going to format all this and run it. Maybe it'll just run. Hello from foo. Not sure why that printed out red, but that is all fine. There we go. Hello from foo. I think it's just part of my computer runs slow. So I'm going to copy this code and put it over into our course outline. Let me put this in too. Know the difference between parameters and arguments. We define our func with parameters, if any. We call our func and pass in arguments, if any. Cool. So there is the first part of just, creating a func. And now let's create another func. And so I'm just going to copy this. Oh, so you can see it. I'll just do it again. Func bar. And this one is going to take in a string. And we'll print out something. Hello, S. And so that's going to print out. So now when we call bar, we're going to pass in an argument. So we're passing in a string and format it and run it. Hello, James. Right? So this string got passed in to this function as an argument. This function is defined with a string as a parameter. Pass in an argument, which is a string. And then that gets assigned to the variable S. And S prints out the value of S right there. Everything in Go is pass by value. What you see is what you get. WYSIWYG. Pass by copy, pass by reference, throw those terms away. I don't care where you're coming from. Everything in Go is pass by value. I'm passing the value James in right here. That's it. Passing in a string. Pass by value. We're going to stick with that phrase, which is the phrase we use in the Go programming language. We're going to stick with that phrase as we learn more and go through this course. But everything is pass by value. So I pass that in and that totally runs. So I'm going to copy this code and put it over.
Okay.
over into our course outline, and there we go. And I will put here, everything in Go is pass by value. Cool. Nice. And what else would I want to do? And then I could return something if I wanted to return something. So foo bar and, I don't know, woo. Okay, so I'm going to call woo, and I'll pass in money, penny. And I need to create func woo. I'll get rid of this now. So func woo. It's going to take in a string. And the scope of this S right here is to there. The scope of this S right here is to there. So don't be confused by an identifier here and an identifier here of the same name. If I wanted to be clear, I could change it, right? But that's why I changed it up here. So to be clear, I'll just do, well, that has bad historical connotations. I'll do ST. And that maybe will help avoid any confusion. But those are different variables. And what I want to do here is I want to return. So I'm going to return, and I can do a func string print. And I can print hello from woo ST. Right? So this is going to print to a string print. It's going to print all that, and then it's going to return that. So I'm going to return a string. So this returns a string, and then I'm going to assign that to there, and then I'm going to print line that right here. Format it and run it. Hello. Woo from woo, money penny. I got a little space there. Hello from woo, money penny. So that is illustrating how we do a return. And if I wanted to, I could have multiple returns. So I will show you that. Course outline, return. So this one up here was a basic func, and this one is takes an argument. That one took an argument. one took an argument, and now we're going to do multiple. And this one will be tang. I don't know if that's a bad word. Wu-Tang? Define. I've heard that. Wu-Tang. A rugby cheer. Yeah, that's a bad word. Okay. So I don't know where I heard that. We will call this mouse. There we go. Funk. Mouse. We'll take in, sure, it'll take in, you know, I don't know, we'll call this first name, last name, string. So you can do it like that. We've seen that. Or you can be a little bit more clear, and you can do it like that. And then it'll return a string and a bool. And now we need to call that in. So we'll pass in Ian, and we'll pass in Fleming. And that's going to return two variables. And so we'll just call this, I don't know, x comma y colon equal. So it returns two variables. And it's returning a string s, a, and we'll do fn, comma ln says hello. Cool. There we go. And we'll do b colon equal is false. And then we'd return a, the string, and b, the false. And we'd return a, the string, parent line, x, format parent line, y. Format and run. Ian Fleming says hello and false. For whatever reason, false. We're returning false. And I would put a little space right here. There we go. Even floating says hello, false. And I change this to true, just to be positive. Format and run. So that's the basic structure of a function. We have the function. Func, and then some identifier, and then the parameters, and then the return, or the returns. If you have multiple returns, they have to be in parentheses, and then you just return to that, and you pass those up. Up, and you can assign them in this short declaration operator, the comma here, and it assigns those returns to it.
Gael Flores, qué bien que te quedó el contador de Gref, jaja, saludos mi chichi. Gracias, gracias. Pues lo puse por ti y ya no lo he cambiado. Díaz, porque bueno tú. Gracias, gracias. Igualmente, igualmente.
Hola, amigo. Buenos dias. Good morning. I feel pretty great. I got a good night's rest. I'm up and going pretty early at 6:41 a.m. Got up 6 a.m. Had a nice shower. I'm ready to get a lot done today and teach you some awesome stuff, starting with functions. I enjoy working with functions. I think it's cool. First thing we're going to learn in this video is we're going to learn about variadic parameters. And so that we saw that the signature of a function has to follow this thing func, and then we're going to have a receiver if we have one, that's optional, and we'll have an identifier, and then we'll have parameters of, we could have an unlimited number of parameters in there, and then we'll have returns. And if we have multiple ones, we need the parens, and then we'll have our code. And so that's the signature a function follows. So let's do one here, func foo, parameters, and that's totally legitimate. That's a function right there. We have the func keyword, we have the identifier, we have absolutely no parameters specified, we have no return, and then we have our code block, curly braces. And then if we were to call foo, and so I could just grab this, drop it in there, and call foo, you have to include those curly braces. That might look like magic code, like why are we doing that? But every time you call a function, you have to specify arguments, even if it's no arguments. So this is calling the function. You need those curly braces, like here are the arguments, and they're none. Okay, so run this function. So that's how you call function. You always have to specify the arguments, even if there are none. So if I was to run this, that's going to print it out. So called foo, which means that my flow of execution, right? My flow of execution, control flow, right? Sequential. My flow of execution in package main, my program starts in main, it enters main, it comes down to foo, it calls foo, so it jumps down to foo, runs this code, leaves foo, comes back up here, exits the program. That's my flow of execution. So now I'm going to create variadic parameters. So I'm going to do x, and I'm going to have an unlimited number of ints. An unlimited number of ints. That's pretty cool. And now I'm going to add those up. First thing I want to do is I want to find out what x is. So I'm going to print x. I'll print x, and then I will also, in case matters, I went uppercase there for a second, you saw that, and I changed it. I'm going to do %t and a new line, and pass in x, and we're going to see what x is. And I'm going to pass in an unlimited number of ints. There we go. 2, 3, 4, 5, 7, 8, 9. I think the reason I skipped 6 is it's the devil's number. I kid you not. That's what went through my head. That's totally wacky. I grew up in my grandfather's a Pentecostal hellfire and brimstone preacher. My mom was a recovering Pentecostal, raised a little bit too extreme, a little bit too fierce. And like my grandpa was the type of guy who would see license plates and be like, devil's license plate. It's weird how stuff sticks in your head. Oh man. All right. So, I don't believe that, by the way, but I guess at some level it's still ingrained in there. So I'm passing all this in. I'm going to format all this, and I'm going to run it. And you can see that it printed out 2, 3, 4, 5, 6, 7, 8, 9, and turned that into a slice of int. So the type here is a slice of int, So that's all you need to know about variadic parameters, right? We passed in individual values of type int, and it received them, and it needs to store them in this variable, so it stored them as a slice of those values, and that's what happens with variadic parameters. And now I have a slice of int to work with inside this function. So if I wanted to add all those numbers up, and this is just FYI coding, everything that, about variadic parameters you just saw, but if I wanted to add up all those numbers, I would need some way to do that. So I'm going to create a variable sum, and I'll do sum : equals 0. That's using the short declaration operator is the preferred way to do it. If I wanted to, I could have also done var sum int, and that would set sum equal to 0. But sum : equals 0 is more readable, it's more clear. So my choice is that, right? Like I'm taking sum, I'm declaring it, and I'm initializing it, initializing the initial time I'm storing it in memory. I'm initializing it, and I'm storing 0 in it. Like that's clear, right? This is, esoteric a little bit. You got to understand that that's the 0 value and read that, which would be okay, but that's better. Now I'm going to range over this stuff. So var index value : equal range, and I'm ranging over x, and then I'm going to do, I could do func print line for item in index position I. We are now adding v to the total. Cool. I think that's good. Which is now. All right. For our index position 1, we are now adding v to the total, which is now, I'm sure I forgot a comma there probably. And we'll do that here for sum plus equals, and we're going to do the value, and we're adding that, and so sum is going to be there. There we go. And then we could do format.println, the total is sum. All right, format all that and run it. All right, 2, 3, 4, 5, 6, 7, 8, 9 for item in index position 0, so that comma doesn't need to be there. We are now adding, and that comma doesn't need to be there, 2 to the total, which is now 2, and then 2 plus 3 is 5, and then 5 plus 4 is 9, and 9 plus 5 is 14, 20, 27. 7, 35, 44. The total is 44. And, you know, we can make this program just a little bit more useful, maybe, if we called this, if we return sum, and then if we said that sum returns an int, and we called this sum, and we called this sum, and then we could just store that to a variable, and we could print that. We could just, you know, do this, because you're looking for the sum, the total is sum x. You're looking for like a function to do something and change something or get a value back, and then you do something with that value. So if I wanted to add up a bunch of numbers, that's how I do it. So format all this and run it, and we have the total is 44, so we're printing out our returned value. So that got returned. So that's a variadic parameter. Never again shall ye be mystified by the lexical symbol, the notation, the dots. Of dot, dot, dot. Last thing I want to point out is let's just go look at the Golang spec, and let's see what we call those dot, dot, dots. You heard me use the phrase lexical element. Lexical element is the big broad catch-all that you use when you aren't sure if it's a keyword or an identifier or an operator. So right now, I got a little gambling game. You a betting person? Where are you putting your money? You putting it on a token, on an identifier, a keyword, or operator, or a delimiter? Where are you going to put your money? On the roulette wheel of which is the lexical element? That's the name of this game. Which is the lexical element? Where are you going to put your money? I'm putting mine right where my cursor is.
Jorge Carvajal, gracias por tu like, bro, en Facebook.
On operators. Let's go take a look. Triple dots. Woo! See you in the next video. So now we're going to learn about unfurling, and that's my word. And I use that word because I haven't found anywhere in the language specification or in effective Go a word for describing what I'm going to show you. I've talked about this before, but now we're going to learn about unfurling a slice. So here's our program from the previous example, and after we do this, we're going to take a look at the documentation for a slice because I like you knowing about the documentation. So now we're going to create a new slice, and we'll do a slice of string, colon equals, and we'll use our slice of int. Sorry, I said slice of string, and I put XS. We're going to do a slice of int. And some people will do XI. Caleb Doxy does it like this. II, it's like, hey, I've got many ints there. I like the X. I think I've also seen him do the XI. But I'm going to take these values here, and I'm going to do my composite literal, which is my type, my curly braces, and then my values. So I'm going to put my values right there. I'm going to format that. I'm going to pass in XI here. Well, sum is asking for int. Not a slice of int, but int, an unlimited number of ints. That's what sum is asking for. And here I've given it a slice of int. This is static programming. An int is different than a slice of int. However, if I go dot, dot, dot after my slice of int, it's going to take those ints and it's going to allow them to be passed in here. I call it unfurling because in my mind, I think of it as like, hey, take all the ints that are stored in here and just unfurl them and dump them right here so that they look like this. Really what happens in the background is the program recognizes that here we are wanting an unlimited number of ints. And here I have a whole bunch of ints, a slice of int. And when I pass in a whole bunch of int values here, it's going to turn them into a slice. So let's just take this slice here and use that same slice there. So it's the same slice that gets used. It doesn't actually unfurl. But that's the way I think of it in my head, so that's the way I talk about it. All right, so that's how you could use a slice of int when what you've asked for is an unlimited number of values of type int, unlimited number of values of type int right there. And that's totally going to run. Kapow! So we did that, and I'm just going to
Mande. Oye, ¿me prestas tu cargador para crear la un ratito? Ahí está.
Copy this and drop this into our course outline, and we will do that right here. Code. Code is good. And on the 8th day, he created code, and he saw that it was good.
Buenas, bro. Buenas, Maximiliano. ¿Cómo estás, hermano? ¿Cómo estás, Maxi?
It's really in some ways like I think of creativity and building stuff as God's work. And by God's work, what I mean is God, if you look at the Western mythology, and I'm not endorsing any one belief system here. I was actually raised by a couple of people who were, in recovery from being steeped in really intense belief systems. And so they sort of embraced all belief systems. In the house I was raised in, there's good in most everything. Look for the good. My dad was a sociologist at the university and studied a bunch of the world's religions. So I'm not endorsing any one belief system, but I think of creativity as God's work, generally speaking, not coming from any one religious background. But God, in many religions and belief systems, created everything, created the world, whatever name you have for God. And so God's work in some ways is creating something. And so coding is creating something. It's building something. So it's God's work. You're doing God's work right now. That's noble. Building something, creating something. I love building. I love creating. All right. So now we're going to take a look at something else. You could actually pass in nothing. When you're asking for a variadic parameter, you can pass in nothing, right? So it's 0 to an unlimited number of arguments. I'm going to run this and it'll run. And I passed in no argument. So variadic means 0 or more of type int. So that's kind of interesting. So I'll just put here also this code and unfurling my word, a slice of int. And in some ways, that's not the best way to talk about it because it misleads as to what's actually happening. It just uses the slice of int that you're passing in as an argument, but it's also asking for values of type int. So I kind of see it as unfurling in my head. Hopefully you see that distinction. Passing in 0 or more values. So here we're passing in 0 values, right? And last thing I want to do is I just want to take a look at the language specification for variadic parameters. If f, and let me bring this down. If f is variadic with a final parameter p, so the parameter is p of type, and you can see my recording equipment there jumping in the background. Let me get this out of the way. Go away. There we go. Now we just see a short one. That's kind of cool. That's my sound. If a variadic with final parameter p of type ... t, within f, the type of p is equivalent to type slice t. You know, right? Like it takes a second to read the language specification. If f is variadic, so the function is variadic with a final parameter p of type ... t, so the final parameter. So when you pass in a variadic argument, it has to be the final parameter. We could do this, right? X slice of int. We could not do this as string. We couldn't do that. And if I passed in, you know, I don't know, nothing, I could pass in nothing there and then just James, right? And it's going to blow up. Cannot use James type string as type int, but I could do this. Fine, right? It's fine. It likes that. It's no problem. So it has to be the final parameter because it's 0 or more. I think that's why. All right. So then within the function, the type of p is equivalent to type slice of t. So within the function, we saw that when we pass in all of these ints, and so we can pass in some ints. The devil's number. We can pass in some ints and run that. And that becomes, the final one becomes a slice of that type, right? The type, so slice of type t is equivalent to slice of t. If f is invoked with no actual arguments for p, the final parameter, the value passed to p is nil, right? So nil means nothing's there. Nil is nothing. Otherwise, the value passed is a new slice of type slice of t. So not only is nothing there, but that slice didn't even get created. It's nil. So the slice will have been created, but the underlying array didn't get created, right? So the slice will have a length, it'll have a cap. Let's take a look. We want this one. Yeah. Length. Cap. Format, we're passing in we are passing in ints. So that time length and cap are 3, and we have a slice of int. Let's not pass in anything. Format and run. And now we have a slice of int, right? And length is 0 and cap is 0. So that underlying array didn't get created. This is pointing, the slice exists, but it's pointing, the pointer is pointing to nothing, to nil. That underlying array didn't get created. So if the function f is invoked with no actual arguments for p, the value passed to p is nil. So that slice gets created, but the underlying array doesn't. Otherwise, the value passed is a new slice, right? Of type slice t with a new underlying array whose successive elements are the actual arguments. A new underlying array whose successive elements are the actual arguments, which all must be assignable to type t. The length and capacity of the slice is therefore the number of arguments bound to p, and p is the parameter, and may differ for each call site. Interesting. And then they give you an example, right? Here, greeting, func greeting, prefix is a parameter and it's of type string, and who is a parameter, it's type variadic parameter string, variadic string. Passing in nobody gets assigned to prefix, passing in hello, Joe, Anna, Eileen, hello gets assigned to prefix, and then Joe, Anna, and Eileen get assigned to who. Within greeting, who, see, it's a little bit funny to read. Within greeting, who will have value nil in the first call, and slice of string, Joe, Anna, and Eileen in the second. If the final argument is assignable to a slice type slice of t, it may be passed unchanged as a value for a variadic t parameter if the argument is followed by ... In this case, no new slice is created. So that's just unfurling. You can see that unfurling here. S is a slice of string, and it has James and Jasmine as values in that slice of string. We take that slice of string, and greeting is this func, which asks for who to be a variadic parameter type string. So we pass in goodbye, which gets assigned to prefix, and then we pass in S, and we unfurl it. That's my word, unfurl it. So basically we're just saying, hey, this is a slice of the type that you want, but I think of it as unfurling. Within greeting, who will have the same value as the same underlying array? Who will have the same value as S with the same underlying array. So the same underlying array. So this array right here that got created, right, it will be the same underlying array. This is a slice, which has an underlying array, so this slice has an underlying array, and this new one here will have the same underlying array, Okay, so hopefully reading that spec, is with me is helping you understand how they talk about, the designers of this language talk about the language, and it's not easy going, and it takes a little bit of like parsing ourselves, right? I found when I talk to people who are really brilliant with computers, like incredible, that they have a language which, is like almost, it is a foreign language. It has a vocabulary and syntax, which is all its own. And so you have to kind of get used to even the language used to talk about programming languages. And so that's part of my intent with reading the documentation with you and with my students is to get them used to that so that you learn to understand this language of programming, how we even just talk about programming, some of the different terms we use. So that's helpful. And I found that when I talk to people super brilliant in programming, like sometimes it's like they'll just shift into binary. They shift into binary. And it's like, it's just like all of a sudden they just Salamat Tinggal. And it's like, wait, what was that thing you just said? Salamat Tinggal? Oh no, that's Indonesian. But they just slip into a whole new language where you're like, well, I don't know that word. So don't be ashamed or afraid to ask when somebody uses something, a term, and you're like, what was that? Like if they say, you might say to them, if they use the word closure, you might say to them, what does closure mean to you? What does closure mean to you? And have them explain it. Don't be afraid to do that. The only mistake in life is not asking questions. So I've said that I really like functions, and functions are fun to play with. I hope you're experiencing some of that. This is where we really get to start to take our program and decouple it, break it up into pieces, and be able to start modularizing it. And I'm just using those words so that you become familiar with them if you're new to programming. So decoupling your code, like instead of having code which is all entwined together and you can't remove any parts of it, to decouple it is to break it up into modular chunks, little modules, which you could just run and swap them out even. And so we might have a function, foo, and we might call foo, and it might add numbers up, and we might implement that using a range. We might range over that slice of int like we did before. And then later we might say, I'm going to change the implementation of that, and func foo is no longer going to use the for range clause. Instead, it will use the init condition post loop. I can change the implementation of that because it's modular. It makes it easier. So it's just decoupling your code, so it's not coupled together tightly, but is in modular chunks. Just using some of the terminology you hear sometimes when talking about programming. All right, so now we're going to learn about the defer keyword. If we look in this language specification, you see we have the defer keyword, and defer will defer the execution of of a function until wherever it's being called comes to an end. So here is a, I guess maybe we can look at the language spec to see how it talks about defer. Defer, and let's go see if it's up here. Defer statements. A defer statement invokes a function. Let me bring this down just a touch. A defer statement invokes a function whose execution is deferred to the moment the surrounding function returns, either because the surrounding function executed a return statement, reached the end of its function body, or because the corresponding go routine is panicking. All right, so let's take a look at defer in action. So I'm going to create one func foo, and have func foo print out foo. And we'll create another one, and we'll call it bar. And at the University of Michigan, in their computer science department, they have a cafe called Foo Bar, where you can get coffee. That's pretty cool. All right, and so now I can come up here, and I can call foo, and I can call bar. And I'm not sure where foo bar originates from. I know it was used in World War II for an acronym for describing somebody who's effed up beyond all recognition. And so I wondered if that's where it comes from, but I think it has some other origin too. If you know, drop me a note. I'm sure we can probably look on Google. Maybe we'll do that at the end of this video. So you can see foo ran first and then bar. I'm going to defer foo, and now I'm going to run this and watch what happens. Bar ran first, and then foo. This has been deferred. When was it deferred? It was deferred to right there. Right when func main exits, anything that's deferred then runs. And so deferring stuff is like, I open a file in my program. I want to make sure that that file gets closed when I'm done with it. Right where I open it, right after I open it, I can say defer, and I can run a function to close that file. And then that's going to ensure that my file gets closed in my program, so I'm not continuing to open and waste resources and use up memory. Because just like on my computer, if I just continue to open tab, that's continuing to take up memory. And if I never close those tabs, eventually my computer will run out of memory. So if we have a program that's opening files, and never closing those files, eventually we're going to run out of memory. We're going to use up our resources. So right where we open a file, we can then run a function
Mm-hmm.
to close the file, and we can defer it. And that's really good code organization, because right where you're opening the file is also right where you're closing the file. You can see that, okay, I opened it and the closing is right there, very readable. And also, regardless of where the function where I open the file is, wherever it exits, regardless of where the function that I open the file in exits, there might be a couple of exit points from that function, defer is always going to run whenever the containing function exits. So that's kind of cool. So that's defer. And what we were going to look up was the origins, foo bar programming define. Let's see what comes up. The term foo bar and foo and others are used as placeholder names, also referred to as metasyntactic variables in computer programming or computer documentation. Foo bar. Foo bar, history and etymology. Foo is obscure. The use and connection of bars generally traced to World War II military slang foo bar, later balderized, that's an awesome word, balderized to foo bar. The word foo on its own was used earlier between 1952 to appear in the comic, who stated that he used the word due to having seen on the bottom of Jade Chinese figurine in Chinatown. Good luck. Interesting. All right, that's enough of that. I will see you in the next video where we are going to talk about methods. We're going to learn how to create methods. That's gonna be awesome. So we'll use the receiver part of functions. So now we're gonna take a look at methods, and to do this, I'm first gonna code up some of the structs so that we can attach methods to structs. And so I start out with my type, and I'm going to do person and then struct and then my curly braces. And so I'm defining my own type, a user-defined type here. It's type person and it's a struct. And now I'm going to put in here my fields for string, and last will be a string. And then I'll create type secret agent. This is my go-to example. And we're going to embed type person in there, and we'll do license to kill, which will be a bool. And then we will do p1 : equal, and that's going to be a secret agent. So I guess I'll do this as SA1, secret agent, curly braces. So that's my composite literal. And now in my composite literal, I'm going to have a type person, so person, and the type, the anonymous type becomes the field name when I'm using it. It's going to be now composite literal, and then a comma. And then down here, we're going to have license to kill, which will be true, right? And then inside person, I got to populate that, and that will be James Bond. And that all looks pretty good. Let's take a look and make sure it's running. Format it and run. Sweet. All right, so we've got that. And now we're going to attach some methods to it. So we've learned that our syntax for a function is func, and then the receiver, and then the identifier, and then the parameters, and then the return or returns. And if they're returns, they need to be inside parens, and then our code. All right, sweet. And sometimes you'll see code like that. They'll just be represented like, hey, put stuff here. Or sometimes you'll see it like this, which means like user input required here. I'm just going to leave it like that. All right, so now let's create a function. So we'll do func speak. And we're going to attach that to anybody who is of type secret agent. Right? So it looks kind of like a parameter, does it not? Right? We could kind of say, hey, speak takes, that argument that has that parameter. But when we take it and we put it over here, it now attaches this function to that type. So any value of that type has access to this method. And you could call it by chaining it with dots. So let's say that again. When you have a receiver, it's going to attach this function to this type. So any value of that type then has access to this method. Let's see it running. I am James Bond. Sweet. And if we had somebody else, and we'll make Miss Moneypenny a secret agent. That would actually be a really nice twist. I would like to see that James Bond series continue, where Miss Moneypenny, right? Like, they're like, M could be like, Miss Moneypenny, you've been a secretary too long. Your country needs you. And she becomes a secret agent. And then, like, she has all the adventures. And it's like a female version of James Bond. And she just becomes, like, totally awesome, empowered. That'd be so great. I'd love that. And then, like, James is even kind of like, wow, I'm very interested in you. And she's kind of, like, indifferent at this point. She's grown. And she's, like, lost her crush on James. Like, yeah, she'll date him, but no big deal. She has adventures. And the world's full of men. That'd be an awesome story. It started here. If it ever ends up in Hollywood, I want to go to the premiere. All right, so now we can do SA2 speak. And you see I'm Miss Moneypenny. So that's a method, and that's pretty cool. And you can see a method. So this operates a lot like an argument or a parameter, right? And the fact that we can use, that right here. And then, yeah, I don't know how else to say that. We've attached this function to any value of that type. We've attached this function to that type. So any value of that type, right? Here's a value. Here's a value of that or a parameter, right? And the fact that we can use, that right here. And then, yeah, I don't know how else to say that. We've attached this function to any value of that type. We've attached this function to that type. So any value of that type, right? Here's a value of that type, which we're storing.
La programación y de objetos aquí en Go, ¿eh? Está como, no complicada, está difícil de acostumbrarte.
Here now has access to that method by just chaining it with a dot, just dot speak. And so that's how you do a method. And Go. That's how you do a method in Go. And it's totally easy. And
Rubén Padilla, ¿qué lenguaje estás usando? Golang. Go. G-O. Es Golang, el lenguaje número 1.
beautiful and ease of programming. Ease of programming. Ease of programming. And it takes a little bit of head shift. If you're coming to this language after knowing other languages, there's always part of the mind that rebels, that you want to do it the way you've been doing it, the way you know, with whatever language you've been working in. Why don't they have this? Why don't they have that? We're working like with Yoda and Obi-Wan Kenobi here. Rob Pike, Ken Thompson, Robert Gressimer. We have to say, okay, I'm in the realm of masters. Show me how it's done. This wasn't a hodgepodge language created by some guy in 11 days JavaScript, right? It was well thought out by some of the best thinkers in computer science. C, the B programming language, the C programming language, Unix and UTF-8, they created that, and now they've created this. Like, we have to be able to surrender what we know and open to a new way of doing things. That's in mind, beginner's mind. So.
Sí, sí, sí. Completamente de acuerdo. Esa cosa está diferente.
Something else I wanted to say there. Zen mind, beginner's mind, surrender, Obi-Wan Kenobi, the masters. I don't know what it was. I was gonna look something up and show it to you. If it comes back to me, I'll show you. So these are methods in Go, and logically, the next thing for us to look at are interfaces. And interfaces are pretty simple. They allow polymorphisms. We're gonna take a little foray right between methods here and anonymous funcs and take a look at interfaces because that is good to know about. Cool. Interfaces are next. So if you feel like this course just sort of like shifted gears and like went from fourth gear to fifth gear, and it's like. It's like accelerating. There's some truth to that. We're dropping into a little bit, more intense material, and we're driving forward a little bit more quickly. But don't let that discourage you. Like, just kind of settle back in your seat and enjoy the ride, and then make sure that you practice this stuff and drill yourself. Do exercises. I'm going to give you hands-on exercises also, but drill yourself and work something until you've got it. So create some structs, some user-defined types, and attach some functions to it. Create some methods, and then use those. Call those, and then when you've got that, okay, cool, go on to the next one. But it's like anything, like any sport, like riding a bike, or playing basketball. It's like practice that layup, practice that layup, practice that layup, and then pretty soon you own that layup, and that's something that you have in your toolkit that you can use in the game. How do you like that analogy? All right, so now we're going to learn about interfaces, and interfaces allow us to do polymorphisms polymorphism. And so to create an interface, I'm going to, and the classic way to talk about this is interfaces allow us to define behavior. And that's kind of like, once you know what interfaces are, that makes sense. But until you know what interfaces are, it's kind of like, what does that mean? So interfaces allow us to define behavior, and then also allow us to do polymorphism. So let me show you what an interface is. So we're going to use the same syntax here, type, and then some identifier, and then like something else right there, like, some other thing. We're going to do type human interface, right? And then we're going to define it, and we're going to say that anybody who has any type that has this method speak is also of type human. So
No mames, esto está más complicado. Chale, 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 chale.
notice just that similarity there, right? Where we do type, secret agent, struct, type, human. Interface, we're creating our own type, or var x int. It's like, here is that the keyword? Where's the top of the language specification? Where's my scroll bar? There it is. I'm way down here. Keywords. So we have var, we have type, right? So we have var and we have type. So we use the keyword and then some identifier, and then here we have some other type. So keyword, identifier, type. Here the keyword is type. So keyword, identifier, type. Just notice that pattern. Because some people get confused, like, oh, how do I declare a variable? Well, keyword, identifier, type. Oh, how do I create my own user-defined type? Well, keyword, identifier, type, right? And or whatever it is, type foo int, underlying type is an int. How do I do an interface? Keyword, identifier, and then type, interface, okay? And if we go and we look at this, right, interface is a type, interface is a type. Noticing the pattern. So any other type that has the method speak is also of type human. A value can be of more than one type. A value can be of more than one type. A value can be, say it with me, of more than one type. A value can be of more than one type. So down here we have a value, and a value right here. That value is of type secret agent, right? So here's the value. It's of type secret agent, and it's been assigned to the identifier, the variable SA1. So this value is of type secret agent, but because it also has the method speak attached to it, it is also type human. So this value is type secret agent and type human. So a value can be of more than one type. A value can be of more than one type. Here, just so we're clear on values, x colon equal 42, right? This value 42 is going to be of type int, right? So value is of a certain type. This value here is of type secret agent and type human. A value can be of more than one type. And so we could do things like func bar takes in a human and then does something. Okay, that's it. I called human. Pretty cool. And we'll start with that statement right there. And so now we could create a person, and we'll create another person right here. And we'll do p1 colon equal. Let's see. So we have speak, and we have speak, Yeah, we'll do P1, and this is going to be a person. And so here's our composite literal. And then we need first, and that's going to be doctor. And we need last, and we need no. So that's Dr. No. We'll mix it up. In this next James Bond movie that we're creating, where Miss Moneypenny becomes the hero, there's going to be a Dr. Yes. I don't know what that looks like. It's more positive, though. And now we'll print out Dr. Yes. V1, printing out Dr. Yes format run. All right, so there's Dr. Yes, cool. And we can see that these are calling speak. And then we'll create another function. And this just gets, you'll get into this as you get into the language. So I'm just introducing you to it. And now we're going to attach to type person speak, right? And we'll do the person speak. That there. We'll do that there. Cool. And so now type person has the method speak attached to it. Type secret agent has the method speak attached to it. So they both have the method speak attached to it. And any type that has the method speak is also type human. And then bar takes a human and I called human. Bar takes a human and you pass a human into bar. That's what we want to show. I was passed into bar. You passed into bar. There, we call it that. And they'll print out the H. Cool. So now each of these, we can do bar. And we can pass in SA1. We can pass in SA2, and we can pass in P1. So notice what happened. Bar is taking a secret agent, This is a value of type secret agent. This is a value of type person. So bar is taking in a secret agent and a person. And it's able to do that because both secret agent and person are also type human, and we've asked bar to take in type human, right? So that's taking in type human. And that's polymorphism. Poly, mini, morph, change, right? So this function can take in...
No mames, en un video te metió todo. No mames. Demasiado, mi pana, demasiado eso.
Types, right? And depending on the types, we could change what that function does if we wanted to. And polymorphism. So that's interfaces, and interfaces allow a value to be of more than one type. And both person and secret agent both have a method speak. So they are also any value of type person or any value of type secret agent. They're also of type human. And so then we could pass around a human and ask for a human. This is really useful because if we go to the documentation and we look at like IO writer, right? And we look at typewriter, and I'm just looking at typewriter, which is a funny type. Right here, typewriter is an interface, and any type that has this method, right, implements the writer interface. And so we could create functionality, like if we go to godoc.org and look at net HTTP, we could look at the index here, and we can see what takes a writer. And we can see the writers that are taken. I'm just looking for, like all these things are taking a response writer, right? And a response writer, here takes an IO writer. The header takes an IO writer. Net HTTP, here takes an IO writer, right? So we could write things. And so writer allows you to pass anything in, and that implements the writer interface. So you could have different elements which work where if they have that method, and they can all implement that method slightly differently. So it's a big thing to wrap your head around, and this is just a start if you're just being introduced to it. But if you are familiar with it, then you're seeing how it works. So let's watch this run. Undefined S and S first. S first. Line 22. P. All right. And I was passed into bar James Bond true. I was passed into bar Miss Moneypenny true. I was passed into bar Dr. Yes. So that's pretty cool. And that's polymorphism. And
No se pasó de lanza.
And I was passed into bar James Bond true. I was passed into bar Miss Moneypenny true. I was passed into bar Dr. Yes. So that's pretty cool. And that's polymorphism. And one more thing I'll say about that, maybe two more things, is that here's my joke. An interface says, hey, baby, if you've got this method, then you're my type. Hey, baby, if you've got this method, if you have this method or these methods, then you're my type. If you have these methods, then you're my type. That's what an interface says. So if you have this method, then you are also my type. And person has that method, so person is also that type. And secret agent has that method, so secret agent is also that type. So that's what an interface says. And then we've seen conversion. So I'll show you conversion. And so just give you an example of conversion. And conversion is if we have var, let me just think this through. We'll come up here and we'll do my own type. So the keyword's identifier, and I need something here, I don't know, hot dog, and the underlying type is an int. And then if I do var x hot dog equals 42, format.println x, format.printf, %t \n x, right? And then format.print, and then y var y int, and y is equal to int conversion around hot dog, right? And then we could do all that with y. So we have 42, we have hot dog, right? And then we have 42 and we have int, because here we did conversion. That's conversion. So now I want to show you assertion. So assertion is you're asserting something is of a certain type. And so now we could do this. And this is just FYI, kind of like a nice tour. It's showing you what's possible and giving you a look at the more intermediate to advanced material. So I can't just say H first, because this might be secret agent, or it might also be person. And so I can do H, that's fine. It'll dump everything out. That totally runs. So we're back to running. But what I could do is I could come up here and I could do a switch statement. So remember we have switch, and we're going to have something there. And if I just leave it blank, it'll switch on, expressions that evaluate to true or false, being the first one that's true. And we'll have cases. I'm going to do switch H, and then I'm going to do type. This is a special type of switch statement where I can switch on type. And then I'm going to say if you're, if the case is type person, do something. If the case is type secret agent, if that's what the type is, do something. And I have some code here, which you can just kind of pause your video and you can see this, and it gives you a little bit of insight into that, including the empty interface. And I'll talk about that in just one second. But again, this is just a preview deal. And so now I could say what I want it to do for each of these cases. And I could use assertion here. So I'm going to assert, and this is different than conversion. I'm asserting that this is type person, and I'm asserting that this is type secret agent. And I know that because I just did that switch. And now I could call first, right? I could call first off of that because I said, hey, you know what? I know this is type person. We just checked it. So let's call first off of type person. So when you have an interface and you need to get back to the concrete type, the type underlying that interface, you can do it this way, format it, run it. And now you can see, and let me just change this so we can see where that is happening. Format it and run it. And you can see here, right, that one worked. I called, James, I called Miss, and I called Doctor. And so that's assertion. So conversion was down here. That's conversion. And assertion is I am asserting. And that's a little bit stronger. Converting, I'm converting that value to a different type, right? And that makes sense. I converted type hot dog, where is it? Converted type hot dog to an int, conversion. Here I am asserting, right? That's kind of like a strong active word. I'm asserting that this is type person. I'm asserting that. And I checked it with the switch statement on type. So that's how you can kind of like, once you have something that's general, you can get back to the specific or the underlying concrete type. Seems like there's one more thing I was going to say about that. I don't remember what it was. I'll rewatch this video. Like, oh yeah, that's what I wanted to say. So that's a whole lot about interfaces and polymorphism. And don't feel like you got to nail that if it's new to you. But if it's something you're familiar with, then it's good to see and good to know about. And as you program, you'll learn more about it. So let me just see if anything else I want to say comes back to me. I guess the last thing I'll share is just a little bit of review. And remember what interfaces do. So interfaces allow us to interface, allows us to interface in a different way. And so a value can be of more than one type. And so an interface says, if you have these methods, then you're also my type. And remember this interface down here, type human interface, right? It's saying, if you have this method speak, you are also of type human. So both person and secret agent have the method speak. So they are also of type human. And that's a common type shared between them. So when we ask for a value of type human, like we do here, right? Either a person or a secret agent can be passed into that. And that allows polymorphism. So that's kind of what interfaces are. And if you have an empty interface, right? So if that's an empty interface, then every other type is going to have no methods, at least. They also have no methods. And so everything implements the type empty interface. So when you see in Go programming something asking for the empty interface, and that's the other thing I want to say, when you see in Go programming something asking for the empty interface, every value can be put in there. And we see that in the documentation. So if we go and we take a look at like, godoc.org, and we'll just look at the funct package, right? And inside the funct package, right here, these are all asking for an unlimited number of types. Here's print line, unlimited number of values of type empty interface. Every value implements type empty interface. And so every value can be put there, or no values, 0 or more. So now you understand this thing, a variadic parameter of empty interface. You understand that. Every type has no methods. They might also have 1 or 2 methods, but in addition, they don't have any. And so they implement the empty interface, and they could be, every value is also of that type. So even an int is also of type empty interface. And so values can be of more than one type. That's a profound concept and provides a lot of power and flexibility in creating programs. So good for you for hanging out for this entire video, because the last thing I'm going to introduce you to is Bill Kennedy has this article on composition. You can just search for Bill Kennedy composition with Go, Go programming. We've been talking about composition, and here he lays out a program which has a nice interface design, right? So creating a struct, and then interface, right, and another interface, and another interface, and he shows you how you can start to build programs using interfaces. So this is a nice document, nice article to read through. And Bill Kennedy's a personal friend of mine, so I feel like I feel really fortunate and lucky. Both Bill and Caleb Doxey, like they're friends of mine, and it's nice. I don't know, it's nice to share the good work that they're both doing in the world, helping people learn about programming, learn about this language. So they're great resources to consult with. All right, so that's a fair amount about interfaces. That's a fair amount about interfaces and polymorphism. And I hope watch this video again if it went a little bit like the concepts are just really new to you. But I hope that gave you some good exposure to how they work. So that's a bit of a hurdle.
Está cabrón.
In that last video, there's some pretty big concepts in there, and I just want to encourage you not to worry about that stuff too much. Interfaces will come a time, and it's good for you just to be familiar with them and to understand when you see things like the empty interface. Okay, here we're declaring an interface. Interfaces allow things to work well together, to interface together. Here we're declaring an empty interface, which means that every other type has no methods. Even if they have methods, they also have at least no methods. And so every other type implements this empty interface. So wherever the empty interface is asked for, I can pass in any other type, and that's pretty cool. So don't sweat it too much if that previous video was like a little bit of a hurdle. That's all going to come a time, just like if you were watching somebody riding a bike and you're just learning to ride a bike and you saw them riding a wheelie or riding without hands, you'd be like, holy cow, how are they riding without hands? It'll come a time. Don't sweat it. Now we're going to drop into some things which are just good to know about functions and a little bit easier to wrap your head around. And this first one here that we're going to take a look at is an anonymous func. An anonymous func. So anonymous function, remember we've been looking at functions like func and then identifier and then parameters and then code, and we could have it do something, and we'll just say hello from foo ram. There we go. And so we've been looking at funcs like that. and we'll do here foo, and then we have to pass in however many arguments need to be passed in, which is in this case none, and then foo is going to run. And so there is a func which is not anonymous. It has a name, and it has an identifier, and that identifier, that name is foo. We can also do an anonymous function. So an anonymous function does not have a name. So we just have func, and then we have code, and then we have so we just have func, and then we have parameters or arguments, and then we have code. And so if we have no parameters or arguments, we could just put this in here, format.println, and anonymous func ran. And then to run it, remember, here is the function foo, and then we have to have these parens to run it. So here's this anonymous function, right? So just like foo was down here, there was the func stuff, and then we just took this name out to make it anonymous, and we have parameters, and then we have our code. And then to run this, we had to pass in however many arguments were there. We had to add those. So we could replace foo in some ways with this right here, right? That's where foo would go. And then there's parens down here to say how many arguments get passed in. Well, we need to include those parens right there too. And so now this will run, and that looks a little bit funny at first when you see it, but here's the function, and now we're passing an argument. So I'm going to format all that and run it. An anonymous func ran, and then we can do an anonymous func where we pass in arguments. So we can say x int takes in an int, and we can pass in 42. Anonymous func ran. The answer, the meaning of life. 42. X. The meaning of life, X. So we're passing in 42, which gets assigned right there. There's our function. And then we're calling our function. So here's our function. And we're calling our function and passing in the argument. We have to pass in that.
Qué mamada. Hola, padre. ¿Eh?
¿En qué momento tendrás un tiempecito para ayudarme a bajar unas cosas al sótano?
Nunca. Mm,
that argument because func takes, right, this anonymous function takes in an int, and so we're passing that in right there. And that's the same thing here. This takes no arguments, and so we're passing in no arguments right there. This takes one argument, so we're passing in one argument right there. That's why you need those little parens at the end of your func. That's what makes it execute. And so now this one will run too. The meaning of life 42. So those are anonymous functions, and you will see them, and they're nothing to worry about. They're sometimes referred to as anonymous self-executing functions, and yeah, and that's an anonymous self-executing function. So a pretty easy one to wrap your head around, hopefully. And if not, just work it a couple of times, and pretty soon you'll get it. So this next one is a func expression. And an expression, remember, is when we have something that comes down to a value. And so the value that we're going to have here is a function, and we're going to assign it to a variable. And that's what's known as a func expression. And so we could come to the Go playground, and let me get a fresh sheet of code here for us. And whoops. Fresh sheet of code there for us. And now we're going to do a func expression. So we want to assign a function to a variable. And so we'll have func and then whatever parameters, and then we'll have the function, and we'll do func.println and my first func expression. And we're going to assign that to a variable. And so we'll just call that f colon equals. And then we can come down here and we can execute f. Okay, so we're not passing in any arguments, so this has no parameters. It's defined with no parameters. But then this right here is stored right there. So you'll hear people say that in Go, functions are first-class citizens. Like, what does that mean, first-class citizen? So when people talk about first-class citizens in a programming language, they're talking about like, hey, this can be used just like any other variable, any other type. It's fine. It's a first-class citizen. It can do what all the other types can do. And so it's not like, you know, some caste system, some third-class citizen can't do what first-class citizens can do. You know, a func is a type just like any other type. It's a first-class citizen, just like the rest of these. So that's just a saying. I don't really care for that saying. I think it's confusing. But right, a function is a type just like an int or a float64 or a string or a slice or a struct or, you know, is a type or a map. A function is also a type. And so just like we could assign an int or a string to a variable, now we're assigning a function to a variable, and then we're calling that function. So let's run this. And cool. And we can also do that where we pass in some arguments. And we'll pass in an int here, and we'll pass in 42. And the meaning, I don't know, this one's getting old. What other meaningful numbers are out there? Like, really, you know, like, you know, the year Big Brother started watching. And it was 1984, George Orwell. And that's the book, 1984, George Orwell's Home and Camera. And so this is kind of an interest. Here's George Orwell's home, who wrote this book, Big Brother. And Big Brother was all about, you know, everybody being monitored all the time, which is the world we found ourselves in right now. 24-hour closed-circuit television recording and operation. George Orwell, novelist and political essayist, lived here 1903 to 1950. I think that's great irony right there. That's pretty cool. Love that. So we'll do that. We'll do 1984. We're passing that in. And we'll pass in X right there. Format it all. And here we are redeclaring F. We want to make this G. Or we can make it F2. We'll leave it G. Whatever. All right. Format and run. So here's Hello Playground, my first func expression, the year Big Brother started watching, 1984. So that's how we do a func expression. We assign a function to a variable.
A la madre. Esto está muy curioso.
All right, so now we're going to see how to return a function from a function. Remember, functions are first-class citizens. Functions are first-class citizens and Go. Not a big fan of that saying, but we're going to see how to return a function from a function, just like we could return an int or a string from a function. We'll see how to return a function from a function. And I'm just making sure I got that code there from the previous one. It ends in capital AM. Good, we've got it. And we'll start this anew. Now we're going to return a function from a function. So we'll do func foo, and we'll just run this, and we'll do a return s, and s will be colon equal hello world. And we're just starting out here. We need to return a string, and we're going to assign that here. Here to s1 colon equal foo. There we go. And now we'll print out s1. Love it. Love it. Hello world. So foo, we're calling the function foo. It takes no arguments. You can see it's defined with no parameters, so it takes no arguments. We call it, foo runs, and it takes the string hello world, assigns it to the variable s, returns that string s, which is returned, and then assigned to s1, and then we print out the value stored in s1, which is hello world. That's nice. I like that. That's like step one. And we'll put that in here as returning code. We'll put that in here as returning a string, and we're doing this because it's easier to sort of see how does returning a func work when you kind of remember how returning a string works. So there's returning a string. Now we're going to do bar, and so we'll create a new function, and that function will be bar, and we're going to have a return here. What's the return going to be? It's going to be a func that returns int. And so now we need to return a func that returns an int. 1984, 42, 2000, and Fahrenheit 451, was it? Fahrenheit 451. That was another book. I don't know that book. Oh well, we're going to return 451. So here is a function, right? It's a func. It's taking no arguments, has 0 parameters in its definition. It returns an int, and here that function returns 451. So just look at that code that's highlighted in blue. That's a function, right? Like that's an anonymous function. If it's up in our code up here, we could self-execute it, put it right there, and we could comment out all this stuff, which would be a hassle. Let's just see if that runs. Cannot use func literal type int as func. Func int return. See, I'm returning, so now I need to catch it. And this is an int. So let's do x. Format run. Cannot use func literal. Func int return 451. Run that. Func literal type int as type func in a return argument. So it's having a problem with this right here. We'll figure that out in a second. Format it and run it. Cool. Nice. So it's returning 451. We're signing it there, and they're printing it out. So that is just to show you func int. And if we were to see the type of that, %t, that's going to be 451 because that's actually running. We're just going to assign the function and not call the function, which makes it execute. Now we're just assigning the function to x. And so that's a func this int. And here func bar is returning func int, right? That's what it's returning. And here this is what we return, func int, which is this. And we don't want to execute it, which is why we were getting in there before. All right, so this is what's being returned, and here it is being returned. So we return that. So right here, we could take this, and we could just do bar. And now bar is going to run. What happens when bar runs? Bar is going to return this, right? Func int, return 451, and that's what gets returned. So that's the return type. That's the type. And we assign that to X, and now we're printing out X. And so func int is what was returned. That's kind of cool. We return func int. If we wanted to, we could run func int. And func int return 451, so we need to to assign that to a variable, and then format.println I. And we'll put a new line there. All right, so let's look through the logic of what's happening here. First, I'll just get this intermediate step and put it into our code base over here, returning a font, step 1, step 2, cleaned up. So we're going to clean this up. So here, what we're going to clean up is foo, this function foo, right? It returns a string, and so here's the string, we assign to s, and then we return s. If you wanted to, you'll see this often. Just return the string. Instead of assigning it to a variable and then returning the variable, just return that string. And that's going to run just as well. So I'll put that in there. And we'll add step 3, cleaned up more. So that's kind of a nice deal where you just return a straight string. So that runs, it returns this, it gets assigned there, it gets printed. We're going to take that out now because we saw how, okay, returning a string, we're returning the type, and here we're returning the type. That's the entire type. And we proved that that's the type right here, right? We're printing out the type of what's returned. So now let's take a look at this code. We'll share that. That's cleaned up. Make sure it's formatted. Share. Copy. Drop this in here. Cleaned up. And we have bar. So here's func bar. It returns a func int. We are returning this func int, right? So this function right here, it's a function that returns an int. So that's a function that returns an int. That's what gets returned. So a function that returns an int. And that when it runs is going to return 451. So when we run this bar, it gives us this function, and we assign it to x. When we look at the type of that, we see that this is the type, the exact same type that was returned, right? So this is the type of this function. It's a type. Look at the Golang specification. It's a type, just like anything else. Functions are types. And so we can return them just like an int or a string. So that's that. And then we execute this function. So this is what has been assigned to x. And when we execute that, this function runs and returns 451, which we assign to I. And then we print out I. And there we go. If you want to clean this up even further, so we've got the 0ww, step 4, clean up. If we want to clean this up even further, we could take, what was I going to do to clean this up even further? We could take this, instead of assigning it to a variable and then printing the variable, we just run it right there. X, done, right? Like this used to be I, and what I was equal to is this, so we could just take that and take out that step of assigning it to I. And so sometimes you'll see that, and you're like, what the heck is happening there? Well, the function X, right, ran. And so we could run this, and it gives us 451, so we can share that. And then we can clean it up even more. And by clean up, it doesn't mean this is the best way to do it, but this is the way you'll see this stuff, and so you should be able to read it and know what's happening. So to clean that up even more, we took bar and assigned it to X and then ran it, but we could also just say that func bar, right? When func bar, what is X equal to? X is equal to this, so let's take that and substitute it for X, okay? How's that? So that's a little bit interesting, right? So bar runs, and it gives us this function, and that's what gets placed right there, and then we run that function. 451. Now, why on God's green earth?
A la madre.
Now, why on God's green earth would you want to do this? Or Buddha, or Allah, or I don't know, who are the other gods? On, you know, whoever's earth. Why on this green earth would you ever want to do this? I'm agnostic, religious agnostic. I believe in all religions. The good that's in them, which is being kind to other people. So if you're a firm believer in one belief system, my intent is not to offend you. So why on this green earth would you want to do this? The reason you want to do it is that sometimes you'll return functions. And so in the net HTTP package, you can see here, I've searched for func in my browser, and I just kind of did this thing where you search for a func right there, right, in my browser. And when I do that, I can look at the index, and I can see all these func definitions where func keywords over on the left. But here, this one is taking a func as a parameter. When we pass a func in as an argument, that is a callback. So it's going to call back. But I might want to create a function that then returns a function that then gets put in there so that, depending upon the situation, I have that function a certain way. So that might be something that you'd use, returning a func. So you could build a func, get it a certain way, and pass it into something else. That might be a situation where you'd use it. All right, so that's returning a func. And the main thing you just want to take away from this is a stumbling block that most people hit when they first see this stuff. Func bar, func int. They're like, what the heck? Remember, function, identifier, parameters, return. This is the return. There's a single one, so we don't need parens around it, right? That's the return. And now we're returning that function, right? And that's the function that gets returned. And so when we call this, this ends up here, and then we execute that. So that's returning a function. So now we're going to learn about a callback. And if you want, right now, you can just pause this video and you can click this link in our course outline and you can go look at the code and you can see if you understand it. That was kind of like the code I did, just sort of like think out an example before I start recording this video. And then you can unpause the video, come back and watch me recode that and talk my way through it, share with you.
Ok. Hola, Edwin Tello. Saludos. Pues justamente ya. Ay, no me ya. Que se acabe ya. Ah, demasiado conocimiento por hoy. Ok, pues bueno. Oye, ¿y de qué te operaron? De... Ahorita te digo qué fue lo que me hicieron, aguanta. Mm, El diagnóstico fue desviación rinoceptal, hipertrofia de cornetes y el procedimiento quirúrgico fue una rinoceptoplastia y turbinoplastia endoscópica. Eso fue lo que me hicieron en mi nariz. Una rinoceptoplastia y turbinoplastia endoscópica. Y pues ya. Bueno, pues muchísimas gracias a todos por ver. Ya se acabó el directo. Espero que les haya gustado. Y recuerden, como siempre digo, rómpanla y siganla rompiendo. Adiós. Oh, ok. Vale, Edwin, nos vemos en la más tarde para jugar Clash. Bye bye.